Did you know roller coasters have a lot to do with physics? In this report, we'll analyze the relationship between roller coasters and physics by looking to the different concepts of physics applied, such as Newton's laws, energy, and force. We test how different external forces affect the ability of the cart to reach the loop without damaging the cart. Algodoo is the software that allows us to build this roller coaster and view the different concepts that are involved in it using the simulations and graphs that it provides, and the investigation of the concepts is backed up by reliable sources.
The different physical concepts that we used in our experiment are the following: Newton's laws, energy, and force. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This is usually defined as inertia. Newton's second law explains how the velocity of an object changes when it is subjected to an external force. When an external force acts on a body, it produces an acceleration of the body in the direction of the force. The law defines the force to be equal to change in momentum, mass times velocity per change in time. The third law states that for every action there is an equal and opposite reaction. For example, if object A exerts a force on object B, then object B also exerts a force on object A, an equal and opposite force.
Energy is the capacity of doing work. There are different types of energy. The types that will be used in this experiment are potential and kinetic energy. Energy can be neither created nor destroyed, but only changed from one form to another.
Friction is a force that resists motion between two surfaces that are in contact with each other. Friction works in opposition to the direction of an object's motion. It is much greater on rough surfaces than it is on smooth surfaces. Gravity is the force of attraction between matter. It is affected by mass and distance. The force of gravity between two objects increases as their respective masses increase, and decreases as the distance between them increases.
In our experiment, we will test the amount of kinetic and mechanical energy needed for a roller coaster to complete a full loop without exceeding the amount of force applied. In this process, we will use the keyboard's keys to apply different speeds to the roller coaster. We will only apply the mechanical force to get past the first hill. After the first hill, the kinetic energy should allow for the cart to go through the rest of the ride with enough force to complete the loop. Therefore, we will see the use of potential energy from the gravitational force and the kinetic energy generated by the cart's movement. We analyzed 3 different components of our experiment: cart velocity, gravity, and energy.
So what is this graph showing? In the beginning of all 3 trials, acceleration is constant until the cart gets to the hill, which causes it to slow down. After that, we can see that there was a sudden decrease in velocity due to the hill of the roller coaster, but after that hill, velocity increases again. This happens because of gravity, which makes the cart accelerate rapidly when it is going downhill. As we can see in the graph, in the case of the fastest trial, the cart doesn't stay on track and flies off, causing the trial to be unsuccessful. The second fastest one is the successful trial, because the cart makes it over the hill and then around the loop, whereas the slowest one doesn't even get over the hill, making this final trial unsuccessful as well.
What is happening in the gravity graph? In this graph, we can see the potential gravitational energy of the cart during the roller coaster. Coincidentally, it looks very similar to the roller coaster itself. When the cart goes up, the potential gravitational energy increases, and when the cart goes down, energy goes down.
What is happening in the energy graph? In this graph, the kinetic energy applied to the cart is seen. Surprisingly, this graph is very similar to the velocity graph. During the first 2 seconds, the kinetic energy increases to 4.4 million joules until the cart reaches the hill, and then for another 2 seconds, it decreases to approximately 2.5 million joules. Once the cart goes downhill, there's another big increase in kinetic energy to over 5.5 million joules. In summary, the faster the cart goes, the more kinetic energy is applied to the cart. After conducting this experiment in Algodoo, we have concluded that for our roller coaster model, the cart's initial speed has to be between 20 meters per second and 43 meters per second. After several trials using many different initial speeds, we noticed that 19 meters per second is not fast enough for the cart to make it over the hill, and 44 meters per second is too fast, considering the cart will be damaged if it reaches this speed. As a conclusion about Algodoo, we can conclude that it is a very useful software that helped us expand our knowledge in physics. The fact that we can construct whatever kind of structure in Algodoo helps us understand how physics affect our everyday world. In this case, we decided to build a roller coaster which included Newton's laws, energy, friction, and gravity as its main concepts. In Algodoo, we would edit the magnitude of these forces to see how it would affect a roller coaster and also view graphs to see how they would change. For this report, we use a velocity time graph, an energy graph, and a gravitational energy graph to compare our different trials and get to these conclusions.
We recommend the use of this software, Algodoo, for educational use in terms of science experiments that are more difficult to recreate physically. Algodoo is a wonderful software that allows you to use all sorts of physical properties to simulate almost anything imaginable. Apart from the wide range of objects like shapes, prisms, water, density adjustment, mass adjustment, ropes, motors, etc., Algodoo also has tons of options to facilitate later analysis of the experiment. It provides data and graphs made on the spot to allow easy analysis later on. It takes a bit to get used to the different aspects of Algodoo, but the initial tutorials are very helpful in getting familiar with the tools of the program.